This video is a response to, or inspired by, a recent Functional Print Friday video about designing a 3D printed counterbore tool holder. I love the video. It was a great example of how to design something real. I want to show a technique that I've been using lately to design stuff. It is admittedly overkill for this particular problem, but this makes a good example, I think. And I'm going to demonstrate some configuration variables and editing things in context. So the task was to make a holder for these counterbore bits. When I'm doing this kind of thing, I really like to start often by modeling the thing that I'm making a holder for, that I'm mounting to. So let's start doing this. I've got a new document here. I'll create a sketch here for our counterbore bits. I think the shafts were like 3, 4, 5, 6, and 8 millimeters. Let's just start with the 3 millimeter one and extrude that. I don't know the shaft length. Maybe it's it was like 20 millimeters, so let's call it 25. And then we had a head on the cutting portion on the thing. So another sketch. I got to learn the key shortcuts for these things because I spend too much time clicking on stuff. So that had some diameter. Oops, let's view this thing. That had some diameter. Let's say this one's 5, I don't know. And we extrude that up, and that's, let's say, 10 millimeters. Now the thing is, I'm going to model this thing, I don't know, maybe 6. If I actually had one, I'd measure it. I'm going to model this thing, and then I'm going to have to make, 4 more, which is kind of a hassle. So let's change this instead so that we can make them in a generic way. We've got these configuration variables. So I can pull this open and add a configuration variable. And let's call this the overall OD. Let's call it OD, and this one's 3 millimeters. Do that. And then let's see, how do I do this? Oh, right. So this makes a new variable, and I can go and how do I do it? Oops, not there. This sketch, I can change this to use that variable. And I can let's see, I can add another variable. So call this cutter OD. Let's make this one 5. And we could add variables for shaft length and such, but I'm not going to bother right now. All these things show up here. Let's add our one more. Add a circle here. Actually, I think, whoops, right. Let's call this OD. This is the smaller cutter. I don't know, 3 millimeters. Okay, now we got our shape. And I'm not going to bother to model the flutes on this because there's no need to go overboard on your model. The main idea is to get an idea of how it's going to look when you've actually got it in the holder. At this point, we can adjust these things. So for one of the bigger ones, maybe it's 5 and 7, or I don't know, 5 and 8. So far, so good. but we can only adjust this one at a time. Let's rename this Part Studio to Counterbore Mill. And actually it's helpful to rename the part. Shift-N, was it? Yes. Okay. The next thing I like to do is go into an assembly, and we're going to, this is where the power of these variables come in. We can now insert these with custom values for these variables. So let's insert one. Great, here it is. So we had a 3, we had a 4, let's call this 4, 6. I can hit generate, and we get 1, and we can plop it wherever we want. And we had that was 3, 4, 5, so 5, 7, generate, stick that one over here. 6, 8, generate. I guess I could have just made that +2 if I had thought about it. And final one is 8. Let's call it 8, 11, just to make it fatter. No proportions. Okay, there we go. So now we have a bunch of these. And actually we can edit these. Right click and say, where is it? Change configuration. You know, maybe this was 6 and 9. Do that and poof, it changes. So far so good. Now we've just got these things floating in space. I kind of wanted them all at the same height. Well, we can just look at them and just manually drag them up, because we're not trying to get precise at this point. We're just trying to get an idea of what would be a visually pleasing arrangement of these. Whoops, let's look at the top. You know, how can we arrange these things so that they will be nice to grab in our holder? There we go. And whoops, that's kind of close together. So, you know, pick out some spacing that looks nice. We could even go a little overboard. Let's create a new part studio. Let's model my thumb. So I don't know, my thumb is, end of my thumb is some kind of ellipse. I don't know how big my thumb is. I'm gonna grab the calipers here and measure. Looks like, I don't know, maybe 20 by 12. So 20, 12. Oh, let's see. Let's actually round this out nicely. I draw a line down the center. Oops, it's hard to see. Then I can revolve this thing around here. Great, and then I can extrude that upward, and that's kind of like my thumb, right? Let's rename this thing. And just so it's not confusing, let's also rename this. And then I can insert my thumb somewhere. And we can try to get an idea of, you know, okay, could I actually grab these things? Yeah, it's looking pretty awkward, so, you know, let's give them a little more space. I can probably stick my thumb in there and manage to grab some. Okay, but we still don't have a tool holder. So the next part that is kind of cool is what's called edit in context. So we're going to create one more part studio. Let's call this one the tool holder. This is the actual, let's put it first since it's the actual thing that we care about. Unfortunately, we have to have a part before we can start editing it in context, as far as I know. Actually, configuration. Is that true? No, there's a way to do this. Let's see, what is it? Yeah, create part studio in context. There's kind of two ways you could do this. Let's do the cool way. We can actually delete this, go back here. There we go, it's one of these things. Create part studio in context. You have to select an origin, which relates to how the part, this is confusing. I usually select the origin. Sometimes it backfires. If somebody really understands how this works, please explain it to me. Okay, so we now have this new part studio, which we're going to call tool holder. Again, let's put it first. But you will notice that the stuff that we already designed is present. The stuff from the assembly is here in this ghostly form. And you can actually control how transparent it is. So now we can start a sketch. What did I just do? I put that on the wrong plane. Let's put that on the top plane. And look at it. And oh, it's kind of awkward. These things aren't centered, but we can fix that later. Let's just draw ourselves a rectangle. And since I just freehanded these things, their positions are extremely approximate. So let's make them less approximate. What's going to look good here? Maybe something like that. And then I'll follow your example. I'll draw a line for here. Let's make it a construction line. And oops, another one along here. And let's put some points for where these guys are going to go. We're not going to make it exact. We're going to try and find some nice mathematical relationship here. Oh, so that's right in the middle. I made that a midpoint. And let's see. I'm going to say that's about a third of the way along there. So I'll use your trick of splitting these. You can split it at that point, split it at that point, split it at that point, and then I can split this once more in the middle. Oh, yeah, I'll split it in the middle, and split this in the middle, and then I can say this, oops, this, that all of these are equal. There we go. Now they're still blue because I haven't constrained other stuff, but they are constrained side to side. And these guys, let's say we want, I think aesthetically these look best if they're halfway between the other ones, which actually I can do with I can say this and this are vertical to each other, and likewise for this and this. And then let's go with that for now. Let's do one more thing. You know, this whole arrangement where it's off center is kind of ugly. So I'm going to say that the midpoint of this edge and the midpoint of this edge, I'm going to say this midpoint is aligned vertically with there. Oops, that didn't work. I think we have to constrain the length of this thing first. Okay, well, 55 is a nice round number. Let's call this 35. Now I think, yeah, we can drag this thing around. We're still missing some up and down constraints. Constrain those vertically, constrain these horizontally. I'm realizing this is not really the greatest example, but let's go with it. And I'm gonna do something interesting here before we go and fix the vertical spacing of these. So now you notice my stuff in the assembly is totally in the wrong place. That's fine. let's say that the bottom of the bits are going to hit those points. So we can extrude this downwards for the amount of material we want below our bits. I don't know, 4 millimeters. We don't need much of a base. Okay, so far so good. Let's keep the sketch visible. Okay, so now, so far we've been designing in this this space here, but it's not reflected in the assembly. We can fix that. Oh gosh, where'd it go? Okay, well remember there's this little box up here that said insert an assembly. It's gone now. If I'd clicked it, the effect I would have gotten would actually have been the same as saying insert this part. And if we just hit the check mark, it ends up at the origin. It is often handy when doing this to use mates to fix this somewhere. But the other approach you can take is to right-click it and say Fix. Oh, I forgot to rename it. I always seem to have the same name for my part studio and my parts, which feels kind of redundant, but there it is. Okay. Wait a minute, where's our sketch? We're supposed to be able to see the sketch here. I think I'm wrong. I guess you can't see the sketch here. I forgot about that. Okay, well, we need somewhere to stick our end mills, so we're going to add some mate connectors. So mate connectors get a owner, and the part that is inserted into the assembly, they only show up in the assembly if if their owner is a part that is included in the assembly. So we want to set that to this part. I realize this is less and less of a compelling example as it gets more complicated. So I'm going to show another example in a bit that I think is more compelling. Also, weren't these supposed to be equal? What's going on here? Hang on. Oh, fascinating. My points got broken in some. This is not what I thought it was. I see. These are leftovers, and these ones. Okay, let me make more clear the ones that are. Oh, this is kind of a mess. Those are the ones that we want our mate connectors on. So this is supposed to go here. That's there. We could even name these if we wanted. Oops. This is probably looking really dumb about this point because this is looking like a lot of work to do something pretty simple. I thought it would be a little more compelling, but I will show my other examples in a bit. 6 millimeters. I probably shouldn't be bothering to name these. Okay, now let's go to our assembly, and poof, all those mate connectors show up, and they're children of here. Okay, now that we've done all that, what was the point of all that? Now we can add some mates, and we can say that this mill, right, we have to actually pick a mate connector. You know what we should do? Because we're always going to be mating these the same place, we'll go back here and add a predefined mate connector here to the bottom of this, owned by Counterbore Mill. Go back to our assembly. Poof, all those mate connectors show up. So now I can say I'm fastening this to that, and there it is. And there's some mode where these, it automatically does another one. I think if I click here, yeah, then I can do another one. I put that last one in the wrong place. Let's just get rid of that. Okay, pull these up so I can actually see them. And let's just hide my thumb. It's not doing anything useful right now. Okay, let's try this again. This guy goes here. No, it doesn't. It goes there. You know what? Let's do these in order. I'm making a mess of this. Okay. Do we show? No. Okay. Well, this one goes here. This one goes here. Our 6mm and our 8mm. Okay, these are now stuck in place. I can't move them. All that work to show you the one particular thing. Let's go back to this tool holder. Notice we lost our context here. If we go back here, right-click on the tool holder, say Edit in Context. Okay, now I'm at this assembly, and you can see our counterbore bits are in the right places. Let's continue. Do this in a somewhat interesting way. So let's pull this thing back up, and instead of just setting a height, we can set it. We can say up to face. Now notice that I'm referencing some geometry that's part of the context, and it sort of turned purple. So if things change in my assembly, that will actually edit where this face goes to. And I'm going to offset that by, I don't know, let's say it sticks out by 8mm. There we go. So there's that. And I can reference these geometries as well. Let's see, can I do it with a Boolean? Yes. So tools. Let's subtract these out. And you notice they show up as part of context one. Target here, and actually just to make some clearance here, we can say offset all faces by 0.2mm. So that made the holes just very slightly bigger than the bits. So you can see I got all of my hole sizes completely for free. And to finish off, I think you had some chamfers on these. Two distances, I don't know, 1 and 4 or something. Sure, looks good. Maybe 1 and 3, that's kind of extreme. And you got a chamfer on the outside. Who cares? We won't bother. Okay, so the interesting thing, suppose something changes. Suppose you discover that your counterbores are a different size than you thought. We could go here and we could say, oh, it turns out this big one, if we change its configuration, it's actually, they manufactured a bit big and the shaft is 8.5mm. There, now it's too big. Actually, let's make it dramatic. 10, 12. There. So you can see it's way too big now. Our part doesn't work. You will also notice there's this little blue dot here. What that is saying is that that particular part was created in the context of this assembly, and the assembly has changed, but the part hasn't updated to represent that change yet. So we can just right click on this, say update context, and poof, what that did was update the context that we see here, and then redid all of the math. So in particular, this subtract ended up subtracting the larger part rather than the smaller part. I'll show this another way. Let's change this thing back to the 8 millimeters that I had before. It was before. Okay, now it's too small and it's sloppy. If we go here, it actually shows this context up here, and it shows that dot, and we can update the context here. Poof, it's fixed. You do have to be a little careful. If a lot changes, sometimes some of your operations break. For example, if that face that we referenced, went away, it would probably break. So sometimes when you update context, you have to go and fix stuff. But generally, it can be really powerful. Also, there's a question about extruding the text easily and cleanly. Let me show you my approach to that. First, let's nail down these floating things here. Since we like the spacing we've got here, we can just lock it down a bit about what it already is. Oops. Kind of like how the bigger ones are, I don't know. Okay, so there we go. Well, that was about 8, 7. Notice at this point our assembly is out of sync, so we can update context, and these things will just shift to reflect the locations that we just updated to. Okay, text. Let's do text. Okay, let's create a new sketch up here. Let's use this, and these are little segments. I'll just grab the 2 endpoints there. Put a line in here. Hide that. Hide that. Okay, we want some text. Let's, as you did, create some new guidelines for it. If anybody knows a good shortcut to start a new line, that would be really helpful. I always end up pressing L twice, which just feels awkward, or escape and L to start a new line. It feels like there should be some way to click or key to just say, don't extend the previous line, start a new one. Anyway, oh right, and let's just put some edges in here. And it's sort of random, feels sort of random whether it starts a new line or extends an existing one. Let's give that a text height, I don't know, 4 millimeters, probably good, and we can say that this one and this one are equal. Press the E key. I'll fix the size of this thing later. This isn't really the point anyway. So this is going to be 6 mil, no, what was it, 3, 4, 5, 3. Oops, 4. Why doesn't text stay selected? Line stays selected after I make something. 5. 6. And 8. Okay, so far we're just doing the same thing you did here. And then you did vertical constraints between, oh, we can use these mate connectors, why not? The mate connectors and the text. And let's just lock in some distances. That text could be closer. Let's do that. That's a little close. Oh, really, I should do it from the edges of the holes, but oh well. Oh, sure. Oh, okay. That's fine. Okay. You were extruding by selecting each of these one at a time. Something you can do is we can extrude by selecting the entire sketch. Whoops, that's a little more than we need. 1 millimeter. There we go. So that's a lot faster. And I try, in general, to make sure that a sketch, all of the solid faces on that sketch are things that I want to operate on together, and then you can select the entire sketch rather than selecting individual things, and it's a lot quicker and easier. And of course we want this to be a little bigger. And we could chamfer the edges and make this look nice, but I think I've made the point that I want to make. Okay, let's put our thumb back, just, why not? Oops. Really, I should be moving this in plane. So, maybe I need to make those a little further apart. Maybe my thumb is too fat, but looks like it would generally work. That was not a very compelling example, but I think it showed the general approach. Let me show an example where I've used this for something far more significant and how it was useful. So I have an antique BMW motorcycle with a sidecar, and the fender, none of the parts match each other. So the tail light is totally mismatched. It's from a totally different year BMW than the fender. And the previous owner made an aluminum bracket to hold the taillight on, and that broke from fatigue stress on a bumpy road. And so I had to go in 3D and design something to 3D print to be a bracket. So the first thing I did was I modeled the fender. This is not quite right. I didn't get all the details, but I wanted to get the curvature in the areas I was mounting to, and I wanted to get the holes that are already present to mate to. So there's my model of the fender. Next thing I did is I modeled the taillight assembly. Again, I didn't bother with everything. There's some turn signal indicators here on the end that don't really matter, but I got the geometry that I'm going to mount to. There's going to be a wire that goes through this hole and some bolts that go through those holes. So I modeled those things, and then I made an assembly. And the first thing I did was I just sort of roughly positioned the tail light where I thought it should go to be, reasonably lined up with the holes, and also, at an appropriate height and an appropriate angle. And I actually created a bunch of mates. I said that it was, I think I said the bottom of it was coplanar with the top plane, so the thing's horizontal. But I didn't completely nail it down. I got it roughly in the right place. And then I created a new part that I edited in context, this one. which is here. And this has, hide these drawings, one of these assembly context. So I created it in the context of that fender. So I could, you can see there's a bunch of mate features here. I could get this thing to mate to the holes in the fender, and then I created mate points on it that I mated to the tail light, and yeah, I kept having to adjust things. So for example, don't I have the wire modeled here? Is that what this is? No. There's a wire that goes through this hole, so I had to get it all lined up. And it's a little hard to show here, but if well, actually something that happened, notice that I had to hollow out an area on the bracket to fit this taillight. The first time I printed this, I discovered the taillight didn't quite fit because I had the shape wrong. And since, like in my previous example, that's a Boolean operation where I just subtract this shape from the solid that I'm developing, I could go back to the taillight. Well, let's do it. Let's go to the taillight. I could change the shape of these things. Let's do it in a really crude way. Let's just say move face. Just take this and blurb it out a bit. There, that's horrible, but I made it bigger. At this point, if I go to the taillight bracket, you can see there's a little dot because in the it automatically shows up in the fender assembly. That sticks out funny. Is it? Oh, that's interesting. It took a little while to update there. It sticks out. If I go back to my bracket, then I'm going to have to update this context. If I update the context, it's going to have to think for a while. It's a non-trivial model. And poof, it's updated. I don't like that, so I'm going to undo it. So I'm going to undo that. I think I can go to here and undo. Yes. Okay, good. Likewise, if I modified the mounting holes, then the mounting holes on this would automatically update. It can be pretty powerful. I did a very similar thing. I modeled my license plate, which I'm not going to show for privacy reasons, and then I created a bracket in context of the license plate. There we go. So there's a bracket for holding the license plate. If that is not compelling enough, let me show another example where this gets really complex. This is the dash for a electric motorcycle that I have that is a prototype. Originally, this dash housing was machined to hold a tablet, and in fact, if I turn off, oh, these are mate features. I don't want to turn these off. This does get confusing. If I turn off this, and this, and turn on this is actually a model of the original Samsung Galaxy Tab that we were using as a screen from 2008. So there's the tablet, which I found a 3D model of. And then all of this stuff was designed in SolidWorks in 2009 and machined out of aluminum for this tablet to fit in. And the tablet is now very defunct, and it never particularly worked well. So I have this space that I wanted to fit my own electronics into. And I can hide some of these, hide this front. You can see there's this plastic back housing with all of these mounting features that are supposed to put pressure on the tablet and hold it in place. And then the front of this thing, let's hide this. If we spin around and look at the front, there's this sort of recess for the tablet to fit into. So it's all very complicated, and that's all already made, and I don't want to modify it. So what I started doing is designing. I found a LCD screen that fits appropriately, and fortunately the manufacturer had a 3D model, so I imported that, CAD. And then I started using, let's hide this stuff. I need some electronics to drive it. So there is a Raspberry Pi. There's a circuit board that mounts on top of the Raspberry Pi that connects to a ribbon cable that connects to the display. There's a USB hub here. There's a Wi-Fi adapter. There's a little breakout board for the touchscreen. And you can see this stuff gets really, really cramped. It was really hard to find an arrangement of everything where it fits and it doesn't interfere with the existing housing, and the cables all route. So I used edit in context here. Let's turn this back cover on. Whoops. I use edit in context here to get everything to fit. And then I created a new part called bezel. Let's hide all of this, which is this plastic 3D printed part that attaches the screen, basically encapsulates the screen and makes something the size of the original tablet, and has mounting points for all of these electronic components. If we hide the electronics, you can see there's all these little mounting features. So if I go to bezel, here it is. There it is, and there's no way I could design this on its own, but with the assembly context, I've got, it's a little annoying with assemblies because stuff gets in the way. So you can hit this hide show instances, and we can turn off, say, the housing and leave the electronics. Maybe make it a little more opaque. And so now you can see how the electronics relate to all the mounting holes, or I could turn off the electronics and I could turn on the housing, and I use that for making sure that the edge of this thing actually butts up against the housing appropriately, and then these features actually press against tabs in the back of the housing. And the really cool thing about all this is, let's suppose, so there's this ribbon cable, and the location of this board is actually constrained by the ribbon cable. Now, where does that ribbon cable come from? I can go to here. We're back in this assembly. Whoops, let's hide that. Hide this part. Right click on this. I can say edit in context. I mean, I can click on this thing and see where it comes from. It comes from some part of this. I can also say edit in context, and we get taken to, oh right, this one's actually in a completely separate document. For whatever reason, I didn't want to mess up my main document by adding this thing. This document, it's taken a while to load. So this has let's hide the context for the moment. Hide the context. What the heck? What's going on here? Oh, wow. Well, I forget why this is so messed up looking. Let's something complicated involving step imports. In any case, I modeled out this ribbon connector, originally as a straight ribbon. Oh, that's right. Actually, the original model had it as a sticking out like this, and I made a sketch out of it, and then I turned it into sheet metal and started adding bends to it to have it bend up here, and then this sketch has additional bends to get it pointed where I want it. So actually, this is a good example. So let's get to the end of that. Okay, here we are. Let's show our context. There's our context. That's where that PCB lands. It seems to be hidden right now, but that's okay. I don't know why this is showing up this way. Let's update our context, see what happens. Not too much. Okay, let's change this angle, which is this angle here. Change it to 50 degrees. That didn't have much effect, did it? Oh, I see. That's here. That's to get the height right. Sorry, this is complicated. Fine, let's change these angles. They're currently 45 degrees. Let's make them 40 instead. Now we're bending that thing in a different way, and it ends up pointing in a different direction. Okay. Oh, right, this is an interesting point. When you have a part that is in a separate document, it only gets updated in the assembly when you create a new version. So we have to say create version. Oh my goodness, okay. Okay, that was confusing. We are now back in our assembly for the dash, and you'll notice this ribbon has changed angle, but nothing is updated to actually match. Let me turn this off. So it doesn't match up with that board. It's in the wrong place. There's also a bunch of new blue dots. So we can follow the blue dots. We can go to the bezel. And say update context. And that's going to get the new version of this ribbon cable and redo the entire plastic bezel to match. So all of a sudden, this mount has gone over here, and this board has automatically moved because the mounting points moved. Let's go back to the assembly. It's updated. Electronics, what's going on? Oh, right. All of these cables are defined to avoid stuff, and so they need updating now. I don't actually want to do any of that, so I think what I can do, I'm going to hit back arrow to go to the previous document, which is going to be one more. No. Bezel. It doesn't seem like it works that way. I'm going to right click on, okay, I'm going to go back to the assembly, edit this in context again, and I don't like that change that we made, so I can go back to this version. Okay, that's now pointed at the correct angle. This one's wrong, right? Resets my view every time. Yeah, that's the one I don't like. Okay, so we go here. We say, I always forget how to do this. How do we revert? Oh, right, we have to go here and then right click on this one and say restore. It's confusing. Okay, now I think we have to create a version again. Okay, and once again, stuff is wrong here, so we've got to update. I think we can, no, we can't. We can go to here and say update context. And that should put it back exactly where it was, I hope. Eventually. I hope this is a compelling example. I realize, okay, that's clearly not exactly where it was because it's now interfering with this cable. Oh well, I'll finish it. I'll fix it after the video. I realize this probably seems pretty messy and complicated, and I won't lie, it is messy and complicated, and I have gotten stuck a number of times with quirks related to this. Oftentimes, I will update the context of a part, and then in the assembly, it moves. It shifts to a different place. And I think there are some bugs involved here. But one thing I have learned is all of these subparts have mate features that I use to mate them in place. And even things like, the bezel, which is entirely defined relative to the housing that it goes inside of. So in principle, I shouldn't have to lock it down. In practice, it wiggles around when I update it unless I actually fasten a mate connector on the part that I'm creating in context to some fixed point in my assembly or some fixed point on the part that it's relative to, if that made any sense. In principle, there's these things, some parts that are created in context of an assembly. There's options that are supposed to lock it to the origin, but it just doesn't seem to work reliably. Anyway, I hope I'm giving the impression that these editing parts in context and the configuration variables can be a really powerful way to create parts relative to existing parts. But it's a little hard to wrap your head around and a little complicated. Anyway, I hope that helps. Thanks.